Welcome guys to our channel. In today's video, we are going to discuss some good problems from a recent JEE test paper. Let us start our solving. Okay. The first problem is saying number of points of discontinuity of fx equal to fractional part of x by 2 plus greatest integer of x by 3 in close 0 to 20 is how many? Okay. So we have to find the total number of points of discontinuity of this function. Okay. In this interval. So we first express this function in terms of a single function like greatest integer function, for example. Okay, so that we can discuss the continuity in a much better way. So this fractional part we can write as this x by 2 minus its greatest integer, right? So we can write this x by 2 minus greatest integer part of x by 2 plus greatest integer part of x by 3. Okay, now see an interesting thing. This part here, this fx is some continuous function plus some problematic function. Okay, the problematic function means that the function causes some discontinuity. So the discontinuity in this function fx comes from this part, right? So we have to discuss this part only for discontinuity. This part we don't touch. So let us focus on this part, x by 3 greatest integer minus greatest integer of x by 2. As we know, the greatest integer function is discontinuous at every integer. So we must take for this function x equal to some multiple of 3. Okay, integer multiple of 3 where k1 belongs to set of integers, and for this function we have x equal to 2k2. Okay, where k2 belongs to the set of integers. So these are the points of discontinuity of these two functions. Okay, but we can observe a thing here that if we take the difference of these two functions, the discontinuity will be removed at the points x equal to 6k, where k is any integer. How? Let us take this case x equal to 6k. Okay, so x equal to 6k, if we calculate a general LHL at this points x equal to 6k. Okay, general LHL will be f of 6k minus, that will be, the first term is same for all the cases, right? This term does not contain any discontinuous part or any problematic part. So then we have at 6k minus this greatest integer will be what? This will be 3k minus 1, right? If we have something less than 6k divided by 2 and we take greatest integer, we get what? We get something of the form 3k minus 1, right? So this will be 3k minus 1 plus this greatest integer will be what? This will be 6 minus divided by 3, that is 2k minus 1. Okay, so this becomes plus 1 minus 1, so 2k. And if we check RHL at this points, RHL will be what? RHL will be f of 6k plus, so this will be 3k, the first term is same. Then we have, instead of this minus 1 here, we have 3k and plus 2k. Okay, so this becomes 3k minus k, that is 2k. And the functional value at this points f of 6k will be what? 3k minus 3k plus 2k, that is also 2k. Okay, so we can see for all these points of the form x equal to 6k, the function is continuous. Okay, so that means at x equal to 0, 6, then 12, 18, all these points the function is continuous. But the other points here we have of the form 3k1 or 2k2, that are, if we note down, 2, 4, 6. So 6 is counted here, so 8, then 10, then 14, then 16, 20, and x equal to 3k1, so this becomes 3, 9, then 15. At this points the function is discontinuous. Okay, So at how many points this function is discontinuous? The function is discontinuous at exactly 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 points. Okay. So option C will be our correct option. Let us move to the next problem. The next problem is from sequence and series. It is saying given two APs, this and this, where Tn and small tn denote the nth term of first and second AP respectively, then we have to find the incorrect statement among these statements. Okay. So this is again a single correct type question. Okay. So we have to find the number of terms which are common, maximum value of the common term, maximum value of the common term. Okay. Sum of all common terms. Okay. So we can say first AP consists of 40 terms, right? And this AP consists of 50 terms. So for this AP, we have the first term equal to 2, right? And the common difference equal to 3. And for this AP, we have the first term equal to 3 and common difference equal to 2. Okay. So what will be our common difference of the common AP or the combined AP here? This common difference of the combined AP will be LCM of D1 and D2, right? So this becomes equal to 6. And what will be the first term? The first term will be the first common term between these two APs, which is we can clearly see here that first term will be equal to 5, right? So we can say A will be equal to 5. So what will be our new common AP? Common AP will be 5, then 5 plus 6, which is 11, then 17, then 23, then so on. Now up to how many terms? That is our question, right? So let us first calculate this capital T40 and small t50 first. Okay. So let us calculate this. Capital T40 will be what? Capital T40 will be, we can say 2 plus 39 times 3. So this becomes 39 times 3 is what? 39 times 3 is, so this becomes 119, right? And this term T50, this becomes 3 plus 49 times 2, that is 101, right? So what will be our number of terms in the common AP or the combined AP? The number of terms will be greatest integer of the smallest last term of these two APs, which is 101, right? This 101 is the smallest last term of this two APs. So this will be 101 minus the first term of the combined AP, which is 5, divided by this. We have the common difference of this combined AP, which is 6. This greatest integer plus 1. Okay. So this, if we calculate, this becomes 96 by 6. So 16 plus 1. So this becomes 17. Okay. So number of terms which are common equal to 17. This is correct. Now let us check option B, C and D. Okay. So we can calculate directly this sum of all common terms. Okay. Sum of all common terms will be what? Sum of this combined AP. This is our combined AP. This combined AP we have to sum up to 17 terms, right? So this will be, we can say 17 by 2 times the first term times 2. So 10 plus this will be 16 times common difference is 6. So this becomes 5 plus 48 times 17. Okay. So 53 times 17, that is 901. Okay. So this option is also correct. Now let us check option B and C. Maximum value of the common term will be what? 107. No, this term is not possible, right? Because the second AP is ending at 101. So we cannot get any term above this number, right? So option C will be our correct option. But this is not going to be our answer because we have to choose the incorrect statement. So option B will be our correct option. Okay. Let us jump to the next problem. Okay. So consider two functions f defined from R to R and g defined from R to R defined as fx equal to x sine of 1 by x when x is non-zero, and it is 0 when x equal to 0. And gx equal to x fx, then we have to pick the correct options. Okay, so this is a multiple choice question. Okay, more than one options may be correct. So let us check this function first, fx. Okay, so we can say clearly the functions of the form. We can say x to the power a sine of 1 by x if a belongs to open 0 to close to 1. These functions will always be non-differentiable at x equal to 0. So this will be non-differentiable. Okay, and if a is greater than 1, then it is differentiable. We can easily verify this by the first principle of derivative, which is we know f dash at any point is given by limit h tending to 0, then f of x plus h minus f of x divided by h, right? So this we can easily verify that this will become limit h tending to 0, f of h minus this will be f of 0 divided by this will be our f dash at 0. So this becomes limit h tending to 0, h to the power a sine of 1 by h divided by h, right? So h to the power a minus 1. So if this limit exists and equals 0, then we can say a minus 1 should be greater than 0, right? That is a greater than 1. So we can remember this direct result of this function, of this type of functions. Okay, so let us check the options. G is differentiable. Okay, so G is what? Gx is x of fx, x times fx. Okay, so Gx is what? Gx we can say this function, right? X square sine of 1 by x if x is non-zero, and it is 0 if x is equal to 0. So clearly G is differentiable, right? So we have G as differentiable function, but f as non-differentiable function. Okay, now in the option it says G is differentiable but G dash is not continuous at x equal to 0. Okay, so this thing is very much important. We know differentiability at a point does not imply that the derivative of the function is continuous at that point. We have to verify this by using the derivative of this function. So we first calculate the derivative of gx and then check the continuity of the derivative at x equal to 0. We cannot directly say that if gx is differentiable, then g dash is continuous at x equal to 0. Okay, so let us check. G dash will be what? Derivative of x square sine of 1 by x. So this becomes 2x sine of 1 by x plus x square times cos of 1 by x times minus 1 by x square. Okay, if x is non-zero, and it is equal to 0 if x equal to 0, right? So we can clearly say this term will be cancelled, x square will be cancelled. So this term becomes minus cos of 1 by x, right? So if we calculate limit x tending to 0, g dash x, this becomes limit x tending to 0, 2x sine of 1 by x minus cos of 1 by x, right? Now see, this first limit will exist, right? This limit will be equal to 0, we know, but this limit will oscillate, right? This will oscillate between minus 1 to 1. So we cannot say anything about this limit. That is why limit x tending to 0, g dash x does not exist. So we can say g dash is discontinuous at x equal to 0. Okay, so g is differentiable but g dash is not continuous at x equal to 0. This option is correct. G is differentiable but f is not differentiable at x equal to 0. This is also true. Both f and g are differentiable at x equal to 0. This is not true. G is differentiable and g dash is continuous at x equal to 0. This is also not true. Okay, so what will be our correct options? A and B will be our correct options for this problem. Okay, let us move to the next problem. Okay, this problem is saying let L equal to limit x tending to minus infinity root under bx plus ac x square minus b mod x divided by x, okay, where a, b, c are distinct positive real numbers, okay. So a, b, c are distinct and positive, okay. This information is very much important. We will see later, okay. Then choose correct options, okay. We have to pick the correct options. Note that this is a multiple correct type question, so one or more than one options may be correct, okay. So let us calculate this limit first. L equal to, we can say, limit extending to minus infinity. This square root will be same, but this mod x will open with negative sign, right? Because x is already a negative number, okay. So this becomes plus bx divided by x, okay. So what form is this? This form is, we know, this is infinity by infinity form. So let us calculate this. We simply take out the power of x here from this square root function, okay. So we get limit extending to minus infinity, then x square we take out. So this x square will come out with a square root sign over it, okay. Then we have inside this square root b by x plus ac, okay, plus bx divided by x. So what will be root under x square? We know root under of something is equal to mod of that thing, right? So we can say this will simply open with negative sign. Why? Because x is tending to minus infinity, okay. So x is a negative number, but we need this mod to be a positive quantity, so we just put a negative sign in front of it, okay. So root of x square will be minus x, as x is a large negative number, okay. So this will be limit x tending to minus infinity, then root under b by x plus ac, this times minus x plus bx divided by x, okay. So if we calculate this limit, this becomes b minus root ac. Now this limit is very interesting, right? Because we can clearly see b equal to root ac will give us L equal to 0. Now what does this mean? B equal to root ac. That means a, b, c must be in gp, right? And a, b, c are distinct positive real numbers, we are saying. So b is positive, right? So root ac will also be positive and defined, right? So we can say if a, b, c are in gp, then L equal to 0. This will be absolutely correct. Now, talking about the cases A and B, if ABC are in AP, then L is positive. Okay. So L greater than 0, this means B should be greater than root AC. Okay. Now tell me, if I have ABC in AP, then B equal to A plus C by 2, right? But we know by the AMGM HM inequality, AM is greater than GM greater than HM, right? So we know B should be greater than the geometric mean of A and C, which is root AC, right? Because we have AM greater than GM, and AM we are saying AM is equal to B. So B should be greater than the geometric mean of A and C. And this will be strict inequality because we have distinct positive real numbers, right? So we can say B is greater than root AC if A, B, C are in AP. So we have L greater than 0, right? So by the same logic, we can say if we consider this inequality, HM is less than GM. So HM in this case, in case of option B, HM is equal to B, right? So this B is less than root AC. So B minus root AC will be less than 0. So option B will also be correct. Okay. And D option, L equal to 0 for all A, B, C. This is clearly not correct. So what will be our correct options? A, B and C. Okay. Let us jump to the next problem. Next, we have this common content, or we can say this is some type of paragraph based on which we have two questions to answer. Okay, let us solve this. So first of all, let us solve this paragraph. This is based on logarithm. So let us simplify this a first. A we can write as log of this, then log of this, then the first bracket, if we simplify, this becomes log of 16 to the power 4 times 25 to the power 8 with base 10, right? So this becomes log of this quantity 16 to the power 4 times 25 to the power 8 with base 10. Okay, then we simplify this further. So this quantity, if we simplify, this will be what? This we can write as 4 times 25 to the power 8, right? And this we can also write 100 to the power 8, which is 10 to the power 16. Okay, so this becomes log of this quantity. Now this thing can be simplified to 16, right? Log of 10 with base 10 is equal to 1. So this becomes 16. So log then 16 with base 4. This becomes what? This is 4 square, right? So this term also becomes 2. And this term is what? Log of 2 with base 2. This is also 1. So this becomes 1 minus 1. That is 0. Okay. So A is equal to 0. Now let us calculate this B here. B is what? 2q minus p, where p and q are what? P and q are this quantities. Okay, log of this quantity is p by q log of 5. Okay, so what is this? Let us decode this. 5 to the power 5 root, then 5, then again root, then 5, then again root. So how many 5s are there? 1 2 3 4 5 6 7. Okay, so this quantity, right? So first of all, we try to simplify this. So 5 root 5 is what? 5 times 5 to the power half, right? Now this square root, this second square root, if we apply on this number, what will we get? We will get 5 to the power half times 5 to the power half times half, right? So this becomes half square. Okay, and then again this third square root, if we apply on this number, 5 to the power half times 5 to the power 1 by 2 square, we get 5 to the power half times half, that is 5 to the power 1 by 2 square. Okay, into 5 to the power 1 by 2 square times half, that is 1 by 2 cube. Okay, and also we have this term, right? This another 5 here extra from this square root, this becomes also 5 to the power half. Okay, so for each step, if we calculate similarly, we can say the pattern is clear. There are how many square roots here? There are 1 2 3 4 5 6 square roots. So we have 5 to the power half times 5 to the power half square into 5 to the power half cube into so on up to 5 to the power half to the power 6. Okay, so this, if we calculate this log of this quantity, this would be log of 5 to the power, this powers we can add, right? So half plus half square plus half cube plus so on up to half to the power 6. Okay, this becomes, if we apply the formula of gp, this will be half times 1 minus half to the power 6 divided by half. Okay, so this becomes log of 5 to the power 63 divided by 64. But here we have this extra 5 here, right? This 5 is multiplied outside with this whole expression. So this 5 we have to again multiply with this number. So this number, okay. So this 5, if we multiply, we have to add a 1 here, right? So this becomes 127 by 64. This is the power of this log, right? So this power we can take in the front of this log, right? So this becomes this times log of 5. Okay, now this expression is equal to p by q log 5, where p and q are co-prime natural numbers. So p and q are clearly this numbers, right? This is p, this is q. So we can say this is our p and q. Let us calculate b here. B will be what? 2q minus p. So 2q is 64 times 2, that is 128, minus p, that is 1. Okay, So b equal to 1, a equal to 0 we calculated, and b equal to 1. Okay, now let us calculate this c and d. So for c we can say it is 1 by x plus 1 plus 1 by y plus 1 plus 1 by z plus 1. Okay, so c is 1 by log of 10 base 4 plus 1 plus 1 by this number is log 20 base 2 plus 1 plus 1 divided by log of 8 base 5 plus 1. So what will be this? If we directly add this log, this 1 we can write in each of these expressions as some logarithm with the same base. Okay, so in this case we have base equal to 4, so we write this as log 4 base 4, and for this case we write this as log 2 base 2. Okay, and for this case we write this as log 5 base 5, so that we can add them easily. Okay, so this becomes 1 divided by log 4 log 40 base 4 plus 1 divided by log 40 base 2 plus 1 divided by log 40 base 5. Okay, so this, if we apply the reciprocal property of logarithm, we can say, we can write this as log of 4 base 40 plus log of 2 base 40 plus log of 5 base 40. Okay, so this becomes 4 times 2, so that is 8 times 5, so log of 40 base 40, this is equal to 1. Okay, so c is also equal to 1. Now let us calculate this d here. So d is what? Let us calculate this here. D equal to log 10 base 2 times log 80 base 2 minus log of 5 base 2 times log of 160 base 2. Okay, so first of all we decompose this log 10 base 2 in terms of 1 plus something. Okay, so what will be that thing? So first of all we need to decompose these numbers into their factors. Okay, prime factors. So this is 2 times 5, this is 16 times 5, that is 2 to the power 4 times 5, this is 5 into 1, right? And this is equal to 80 times 2, so we can say 2 to the power 5 times 5. Okay, now we can apply the property of logarithm to simplify them. So this will be what? Log of 2 times 5 with base 2, that will be log of 2 base 2 plus log of 5 base 2, right? So this will be 1 plus log 5 base 2, this will be 4 log 2 base 2 plus log 5 base 2, right? So this will be simply 4, so 4 plus this number plus minus, then we have log of 5 base 2 times, this will be simply 5 plus log of 5 base 2. Okay, so we have to simplify this becomes 4 plus log 5 base 2 plus 4 times log of 5 base 2, that is 5 times log of 5 base 2 minus 5 times log of 5 base 2 from here, and here we have minus log of 5 base 2 whole square, and also we have here plus log of 5 base 2 whole square. Okay, so we can see clearly this cancels this cancels this. Okay, so d is a constant, d is equal to 4. So d is equal to 4, that means this. So now we have to just check the options. Okay, so one or more than one options may be correct. Okay, so we got a equal to 0, b equal to 1, c equal to 1, d equal to 4. That means 0, 1, 1 and 4. Okay, this is a, b equal to 1, c equal to 1, d equal to 4. A plus 2b plus 2c is equal to, so a is 0, 2b plus 2c equal to 4. Yeah, that is true. 2a, that is 0, c plus d equal to 5. Okay, that is also true. A square plus d plus b So b plus d, 5, then a square is 0. So this becomes 5 plus 0, that is not equal to 6, right? And a square plus b square plus c square plus d square. So 1 plus 1 plus 16, that is 18, right? So this is also true. Okay. Which of the following is oblique are true? B c square d. So 1 times 1 times 4, that is 4. Okay, correct. 2b plus d equal to 6. 2 plus 4 equal to 6. Okay, correct. Then 1 plus 1, 2 plus 16. No, that is not correct. A square plus d plus b. D plus b, that is 5 plus 0. Not correct. Okay. So in this case, our correct options are A, B, and D. And in this question, we have correct options as A and B. Okay. Let us jump to the next problem. Okay. Given fx equal to signum of this function, where signum of x denotes the signum function of x, lambda belongs to the set of real numbers. In the list 1, there are values of lambda, and in the list 2, there are number of points where fx is non-differentiable. Match list 1 with list 2 and select the correct answer using the code given. Okay. So first of all, we need to find the functions. Okay. So fx equal to signum of this function, right? So we know signum of x is 1 when x is positive, and signum of x is minus 1 when x is negative, right? And signum of x is 0 when x is equal to 0. A short and simple function. Okay. So we know this function will be not differentiable at x equal to 0, right? Signum of x is not differentiable at x equal to 0 because the graph of signum x looks like this. This function comes from minus infinity as a straight line parallel to the x-axis, and then at x equal to 0, this function has a sudden jump, then again it continues as a straight line. Okay. This is the graph of y equal to signum x. So what does this mean? This means that whenever this quantity inside this signum function changes its sign, the function becomes non-differentiable. Okay. So we have to determine at how many points the function inside this signum function changes its sign. Okay. So the function inside this signum function is what? X square minus 4 mod x plus lambda, right? So this we can write as mod of x square minus 4 times mod x plus lambda. Okay. This is our function. Let's call this gx. So we have to determine at how many points this gx here changes its sign. Okay. This is our question. So first of all, let us draw the graph of this function. Okay. Mod of x square minus 4 mod x. So if we try to draw the graph here, x square minus 4x is what? X square minus 4x looks something like this. Okay. This is 0, this is 4. Okay. And this point is, we can say 2 comma, this will be 4 minus 8, that is minus 4. Okay. 2 comma minus 4. So what will be the graph of mod of x square minus 4 mod x? We know if we want to transform this fx into f of mod x, we need to erase the negative x-axis part of this graph of y equal to fx and take the mirror image of the remaining graph above y-axis. Okay. So this graph will look something like this. Then this part is erased. Okay. So instead of this part, we have the mirror image of the right hand side. Okay. About this y-axis. So the graph looks like this. So this point is minus 4. Okay. So this is the graph of fx equal to mod of x square minus 4 mod x. Now let us check this entries here. So in case of lambda equal to 0, we have the same graph as this, right? So at how many points this function changes its sign? It changes its sign at exactly 3 points, right? Here it becomes negative from positive, 1 point. Then at this point x equal to 0, this function temporarily becomes 0, but then again becomes negative. So that is why there is a change of sign, right? So at this point also there is a discontinuity, so we can say there will be some non-differentiability, right? And also at this point, so how many points total? We have 3 points, right? So p matches with 2. Then for lambda equal to 4, what will be our graph? Mod of x square minus 4 mod x plus 4. So we have to shift this graph by 4 units towards the positive y-axis, okay? Because lambda is positive, it is equal to 4. So we have to shift this graph of mod of x square minus 4 mod x in positive y direction by 4 units, okay? So the graph, the new graph will look something like this, okay? Like this. So as this point was previously 2 comma minus 4, this will be, the new point will be 2 comma 0, right? So then how many points do we have here where the graph changes its sign? We have total this point and this point, right? So total 2 points, okay? So this q matches with 4. Then if we check for lambda equal to 5, so this was the case for this graph, right? But we have to then again shift it by 1 unit further, okay, in the same direction. So we can say the new graph will look something like this. Let us draw like this, okay? So now this function mod of x square minus 4 mod x plus 5 does not touch the x-axis, right? So there will be no change of sign. That means this function signum of mod of x square minus 4 mod x plus 5 will be differentiable for all real numbers, okay? So that means we have 0 points total. So r matches with 1, okay? Then for lambda equal to 2, let us redraw the graph. So this was the original graph, right? Mod of x square minus 4 mod x. We shift it in the positive y direction by 2 units, okay? Like this. So this point, the new coordinates of this point will be 2 comma minus 2, right? Okay, let us redraw this because this is incorrect. So actually this point will also shift, right? Like this. So this point, the new coordinates of this point will be 2 comma minus 2, right? So how many points are there where this graph changes its sign? We can say this point, this point, this point, and this point, right? So total we have 4 points where this graph changes its sign, right? So at 4 points this function will be not differentiable. So ace matches with 3, okay? So 2 4 1 3, let us find the matching. Okay, option A will be our correct option, okay? Let us jump to the final question of this session. Okay, so we have a1 equal to 2, an plus 1 equal to an square minus an plus 1 for n greater than equal to 1. We have to find this quantity, okay? Half times summation n equal to 1 to infinity 1 divided by an, okay? So we are given some sequence in terms of a recurrence relation, okay? We have to manipulate this expression so that we can reach the expression of this form, okay? 1 by an. Let us try. So we write this expression first. So then what will be our next step? We can subtract an from both the sides, okay? So we get an plus 1 minus an equal to an square minus 2an plus 1, okay? So this term is a perfect square, right? This is an minus 1 whole square. So we can write this as an plus 1 equal to an plus an minus 1 whole square. Now we can see a thing clearly that an is an increasing sequence. Why? Because we have an plus 1 greater than an for all an, right? An, if we put n equal to 1, here we get 2 minus 1, that is 1, 1 square plus a1 is 2, right? So we get a2 equal to, this will be 2 plus 1, that is 3. Then a3, if we check, a3 will be a2 plus 3 minus 1 whole square. Now this is clearly greater than a2, right? So for all general n, we have this recurrence relation. That means we can say an plus 1 is greater than an for all n. Okay. So if we try to write this given recurrence relation here, an plus 1 equal to this, we can take this 1 in the left hand side. So we get an plus 1 minus 1 equal to an square minus an, right? That we can write as an times an minus 1. Then if we try to approach this by taking this an times an minus 1 in the denominator of the left hand side and this in the denominator of the right hand side, we get 1 divided by an plus 1 minus 1. Okay, now see this thing, this LHS we can clearly express as difference of two terms. Okay, so the two terms will be simply 1 divided by an minus 1 minus 1 by an. So we simply express this 1 as an minus bracket an minus 1, then split the terms. Okay, so we get this relation. Now see, if I take this 1 divided by an minus 1 in the LHS of this equation, we get some telescopic expression, right? So let us apply this funda here. So we get this right hand side will be minus 1 by an. Okay, so let us do another thing. This 1 by an we are taking in the LHS and this term here we are taking in the right hand side. Okay, so we get 1 divided by an equal to 1 divided by an minus 1 minus 1 divided by an plus 1 minus 1. Okay, then we apply summation all over this equation. So the left hand side is what we have to calculate and the right hand side is a telescopic expression. Okay, so this minus this. So let us calculate this. This will be simply, we can say 1 divided by a1 minus 1 minus 1 by a2 minus 1 plus 1 by a2 minus 1 minus 1 by a3 minus 1, so on up to, we can say, if we express this in terms of limit here, so limit m tending to infinity, so we are expressing this summation in terms of limit. Okay, this is n equal to 1 to m, then 1 by an minus 1 minus 1 by an plus 1 minus 1. Okay, this is nothing but 1 divided by a1 minus 1 minus 1 divided by am plus 1 minus 1. Okay, so this first term is known to us already, right? A1 is known to us. This is equal to 2. Okay, so 2 minus 1 is 1, so this becomes 1. The second term will be equal to 0. Why? Because am plus 1, if we tend m towards infinity, this denominator part will approach towards infinity, because we already discussed that an is an increasing sequence, right? So for each n, if we try to calculate an, we get that the terms are increasing. So if n is tending to infinity, that means the terms will be also tending to infinity, right? So if we take the reciprocal of the term a m plus 1, when m tending to infinity, it will tend towards 0, right? So the limit will be 0. So this we have 1. So we can say this summation n equal to 1 to infinity 1 by an will be equal to 1. Okay, so we have the answer of our question equal to half times 1, that is 0.50. Okay, this is going to be our answer. If you enjoyed the session, make sure you like the session and subscribe to our channel for more such JEE related contents. Okay, and also share this video with your friends and fellow aspirants. I will keep bringing such questions from recent test papers. Okay. Thanks for watching.